So 4-5 is a continuation of 4-4, which focused on factoring. In this particular section, we're going to take the factoring step one to a further place of finding its solutions. Now, back in chapter 3 or so, we talked about solutions, and I gave 3 other vocabulary words that went along with it to help you understand what it means. Not only are they called solutions, but they are also called zeros, roots, and x-intercepts. So I want to show you what exactly this is going to entail for us. So let's say we're finding the zeros here, okay? So the first thing I can do with this particular problem is factor out my GCF. And when I factor out my GCF, I'll be left with an x squared minus 6x plus 9 because my GCF is 2x. And from here I can do my normal x factor where I have negative 6 on top, 9 on the bottom, and pretty quickly I can see that my two factors that will make this statement true are going to be 2x times x minus 3 and x minus 3. So I'll have 2 of them. And most of the time we would stop here. But for this section, we're going to set each piece equal to 0 to find the zeros, or the solutions. So the first portion that's not inside the parentheses, that's going to be set to 0. And I could even, I can solve this one while I'm here anyway. Divide by 2 on both sides. Well, 0 divided by 2 is just 0. And then I do the same thing with the next one. X minus 3 equals 0, add the 3 on both sides to get x equals 3. And I could do it again for the other parentheses, but it's the exact same thing, so I'm not really going to worry about it. What is important to note here is that since there are going to technically be two of those 3's, because again, I had 2 of these, I did the work for one, I could do the work for this second one, but it would be the exact same answer. So I just put a little 2 down here to represent that technically I have more than one 3. So if these are my zeros and it's technically my x-intercepts, then what would it look like on the graph? Well, this is what this graph would look like in particular. So notice how it crosses at the 0, okay? And as it goes up and then comes back down, it goes back towards the 3 and it touches it, but it doesn't actually cross it. And so if you think about it, the 0 would cross here, the 3 touches down, and then it goes back up. And so if you think about it in sort of those terms, you can even see the multiplicity. It approaches from the negative side. It approaches from the positive side. And that is why we have multiplicity there. So multiplicity is when a factor appears more than once, and it will touch the axis, but it will not cross the axis. When a factor is raised to an odd power, the graph is, again, odd could be like 1 or 3 or 5, etc. That is going to be when it crosses the x-axis. But if the factor is raised to an even power, 2, 4, 6, the graph is going to touch. And so if we look up here and we were to take these 2 pieces and rewrite it, technically we could write it as x minus 3 squared, and we could set that equal to 0. And then it's a little bit easier to see that this is actually raised to an even power because it's combined together and I have 2 of them, so the x1 is 2. So from here I could get the exact same answer. I could take the square root of both sides, get x minus 3 equals 0, and then add it from there. Either way, it doesn't really matter. You can either approach it as it is squared, so you think about it as an even power, or you can just know, okay, you can do the work here, and then you know there's 2 of them, so you can put a little 2. It doesn't really matter. Multiplicity is pretty straightforward. So continuing on with this idea, we have example 1.1 and 1.2. And I'm actually going to do all of these because it's just such good practice, especially since we just went over that factoring section, and reviewing over that is very important considering that the factoring is just going to keep occurring again and again and again. So in example 1.1a, the one over here on the left-hand side, my GCF is going to be x, and I'll get x squared plus x minus 6. From here I can do my x factor, and I'll see that 2 and 3 is what I need, specifically a positive 3 and a negative 2. So we'll say x times x minus 2, x plus 3. Typically, this is be where we would stop, but because we're asked to find the solutions or find the zeros, remember it all means the same thing, we are going to set each piece equal to 0, even that front piece. So it's going to say x equals 0, x minus 2 equals 0, and x plus 3 equals 0. The first one, there's not really anything to do, so we can just carry down x equals 0. The second one, add 2 on both sides, and the third, we would subtract 3. So our final answer would say x equals 0, 2, and negative 3. Same thing with b. Underneath it, we have a GCF. We'll factor out a negative 2x to the fourth minus 8x squared plus 16. And the reason why I factored out a negative 2 as opposed to a positive 2 is because technically I'm not, and I mentioned this when we were doing our factoring by grouping, but technically you are not allowed to have your first term be negative. And so that's why I took out a negative 2 instead. From here, even though we have x to the fourth and x squared instead of x squared and x, we're actually going to do this exactly the same way that we've been doing, but our answer is just going to say x squared at the end. So we're going to do our x factor, and we're going to find pretty quickly we need 2 negative 4s. So it'll be x squared minus 4 and x squared minus 4. And again, the reason why I have x squared now is because my highest is x to the fourth. So if I were to just do x times x, that would just give me x squared, but I need x to the fourth. So that's why I have x squared times x squared, because that is what gives me my x to the fourth right here. And from here, I can actually factor a little bit more. This is a difference of squares. So if you remember a difference of squares, we're going to have to take this and take the square root of our x squared and the square root of 4, and that's going to, we're going to consider the positive case and the negative case. So it'll read x plus 2, x minus 2. And the same thing happens over here, x plus 2, x minus 2. And then we'll carry down this GCF. And so technically, we can actually rewrite it again. Notice how, again, we have our x plus 2, x plus 2, right? So I'm going to put those two together, and it's going to say x plus 2 squared. And I'm going to do the same thing with my x minus 2 squared. And this would be my final answer. I mean, I guess I could have stopped up here with this long line of stuff, but I wanted to make it a little bit more condensed, a little bit easier to work with. But again, we need to find our solution. So we're going to set each piece, even that negative 2, which obviously negative 2 equals 0. So that's not even a true statement, so I can cross it out because it's not true. And then I'll do the same thing with x plus 2 squared. Take the square root, and we would, technically we would have x plus 2 equals 0, and then subtract it to get x equals negative 2. Same thing with the other one, x minus 2 squared. Take the square root, we get x minus 2 equals, and then add that to both sides to get 2. And technically, both of these items have multiplicity, so we're going to write this out. Negative 2, positive 2 with multiplicity of 2. And again, I know it's a 2 down here because that's what this problem started with. It started with a squared. And so what I want to point out in this particular section is that if you have the positive and negative, we used to write it where it was a plus, let me write that, a plus and minus symbol. Here we go. When we put a plus and minus symbol. But because we're working with multiplicity now, if I were to put a 2 here, you don't know if I'm saying 2 of each, or 2 of the positive 2's, or 2 of the negative 2's. And so because of that, we're going to write this out and put the multiplicity underneath it. Another thing to notice is that in both of these problems, our highest, well actually in the first one, our highest exponent was 3, and we ended up with 3 zeros. And with multiplicity, we have the same idea. Technically, this is 2 answers, and this is 2 answers for a total of 4. So what's our highest exponent? Well, it's 4. So we can see that with the correct multiplicity and the correct solutions, if we add all of them up, it should equal our highest exponent. Okay, so the next one is grouping. So we need to separate this by cutting it in half. So it's going to be like this, and my GC of the first one is going to be a negative x squared. Remember, it's going to be negative because we can't have our first term be negative. This will give me x plus 1, and then I'll have a GCF of 9 in the other one. My 2 parentheses are equal, so they're going to come together, and my 2 pieces here are also going to come together. Unfortunately, when I do that, my first term here is positive, or negative, so I need to extract out or factor out a -1 so that it is no longer negative right here. So I'm going to factor out a -1, and it's going to say x plus 1. This I just carried down from here. And then in here, all the signs are going to flip. So this negative x squared is going to become positive x squared, and this positive 9 is going to become a -9. And now we have the same situation that we had up here. We have a difference of squares. So this is going to give me x plus 3, x minus 3. Carry down everything else, -1, and x plus 1. And I cannot combine anything here, so this is technically my answer, and then I can set each piece equal to 0. So -1 equals 0, that doesn't work. X plus 1 equals 0, that's going to give me -1. X plus 3 equals 0, subtract that to get -3. X minus 3 equals 0, add that to get a positive 3. So now I'm going to write out all my answers. This is going to be x equals -1, -3, and positive 3. And that is the answer. Same idea with 1.2a. We factor out our GCF. We have to the 4th, okay, so we know that our answer is going to end up with x squared in a second. We'll do our x factor, and we can see that we should have 1. So it should be x squared minus 1, x squared minus 1. And both of these are in the exact same predicament that was happening over here. I have squared because x squared times x squared is x to the 4th. Same here. X squared times x squared is x to the 4th. And I'm going to factor out x squared minus 1 to give me x plus 1, x minus 1. And I'm going to do it twice because I have 2 of them. Carry down that 3. Always carry down that 3. And now I can combine the x plus 1s to get x plus 1 squared and the x minus 1. And technically, this is our answer for factors. Then we set each piece equal to 0. Remember, if it's just a number, it does not work. Then we set each of the parentheses up here equal to 0. So it's going to be x plus 1 squared equals 0, and the other one as well. Take the square root of each one, so we can get this to equal to 0, and then we can subtract 1. Same idea with the next one. We'll get x minus 1 equals 0, add 1 to get x equals positive 1. So then we put our answers. We'll say x equals -1 with multiplicity, and x equals positive 1 with multiplicity. And then that is our answer. Same idea for the next one. It's the same thing over and over and over. We want to make sure that we've got this down. So we factor out the 4. We find pretty quickly that the factors of 9, we need -1 and -9. This will give us x squared minus 1 and x squared minus 9. Again, notice we have to have this squared here because this is x to the 4th. This one is going to give me x plus 1, x minus 1, and this will give me x plus 3, x minus 3. Carry down that 4. And since nothing is the same, that's our answer, but we're going to set each one equal to 0. With the 4, it doesn't work, but with everything else, it does. So we'll end up with the answers of x equals -1, positive 1, -3, and positive 3. Sorry about that. My video cut out. I don't know exactly where we were, but we're going to continue on the 1-2 part B. Hopefully that was right near where we were. But the first thing I'm going to do here is I'm going to factor out my GCF, and I'll get x to the 4th minus 10x squared plus 9. Now it's like a normal trinomial, so I'm going to go ahead and do my x factor. I have 1 and 9 and 3 and 3, but I need the -1 and -9 to get my -10. So remember, when you're doing this, you want to take that x to the 4th and separate it evenly between your binomials. So the only way to make it even is to divide by 2, and you'll get x squared minus 1 and x squared minus 9. There we go. Now that we have that, we can have our difference of squares with our x squared minus 1. This will give me x plus 1, x minus 1. And then we can do the same thing for x squared minus 9. That'll give us x plus 3, x minus 3. Remember, when you are doing this, you need to take the square root of each side. So a common mistake that I see here is people really want to bring the 9 down. Well, you need to take the square root of that, and the square root of 9 is 3. All right. Well, there's no repeats. Oh, let me actually carry down my 4 here. Carry down that 4. And this is our answer for the factors, because I don't have anything that's the same. Like up here we had x plus 1 and x plus 1. We had 2 of them. So we put them together and we have our exponent. right? Well, unfortunately, down here, we don't have any that are the same. So it actually makes it a little bit easier whenever we try to find our solutions. I'm going to set each piece equal to 0. It doesn't work for that leading coefficient or for that GCF of 4 right there, but everything else that we set to 0 is going to give us an answer. Specifically, we're going to get -1, +1, -3, and +3. So I'll write it nice and big over here. And I do not have any multiplicity with this problem. So the letter C, remember the first thing that we have to do when we're doing problems like this is we need to make sure it equals 0. We need everything on the same side. And currently I have that equals 14x cubed. That's not on the right side. So I need to bring it over. And when I bring it over, I need to make sure it is in standard form. So notice how x cubed is higher, if you will. The exponent number is at least the 3. Is higher than x to the first power. So when I rewrite this, I'm actually going to put it after my x, 2x to the 5th. All right, so I have to subtract to bring that over. So it's going to say 2x to the 5th minus 14x cubed plus 24x. And now I can try to factor any GCFs that I have. 2x is able to be factored out. I get x to the 4th minus 7x squared plus 12 is equal to 0. And again, we don't really need the equals 0 part right now, but we're just doing it to be consistent with our problem. From here, I'm going to do my x factor. I'm going to do -7. I have the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And it looks like the 3 and 4 is what I need. So I'm going to rewrite this as 2x times x squared minus 3. X squared minus 4. And in this particular one, this one is not a difference of squares. Remember, to have a difference of squares, we need a perfect square, which we have, and a minus sign, which we have, and then another perfect square, which we do not have. So this is completely factored. However, the last one is like what we're used to. So we're going to do our factors and get x plus 2, x minus 2, and then carry everything else down. And this becomes my completely factored form. From here, I can find my solutions, because remember, the whole point of this particular lesson is just to focus on those solutions. I'm going to carry down the each piece. The first one is going to give me 0. And when I work on this next one, though, it's going to have to add 3 on both sides to get x squared equals 3. And then from there, we need to take the square root. We should get positive and negative square root of 3. And then the other two are very easy, very straightforward. We get -2 and +2. So when I write out my list, and it's very important that we write it out with everything so it's easier to see, you know, what we have and what we don't have. I'm going to put 0, -3, square root of 3, and negative square root of 3, and then 2 and -2. And that is my answer. So if you're in standard class, you can actually sort of skip ahead at this point. But if you're in honors, you do need to pay attention just a little bit, because part of the steps that you are required to take are using the rational root theorem, which basically is merely a starting point. It's a starting point to find possible, or solutions that are possible. It only gives possibilities, that's what I'm looking for. So in the example below, we have our equation right here. And step 1 says we're going to list the factors of the constant and the leading coefficient. So my constant is the 20, and my leading coefficient is the understood one of the x cubed. So that's going to give me 20 here. And the factors of 20 are 1 and 20, 2 and 10, 4 and 5. And then my leading coefficient of 1, well, there's only 1, which is 1. I mean, I guess I do 1 times 1, but just 1. And then step 2 is to list all those possibilities. And when you list the possibilities, you want to take the positive and the negative case. So this would be positive and negative 1 over 1, positive and negative 20 over 1, etc. And we're just going to keep going until all the numbers have been used, all the factors of our constant. So if we had like a leading coefficient of 2, we would do all the steps for 1, and then we would do everything again, but then put a 2 underneath it for this fraction. And I'm going to avoid doing problems like that because it's very long and strenuous when you do it. But I am going to rewrite these and make them not fractions, so this is what it should look like. And then the next thing is we're going to test possibilities. So this is for if you don't have a calculator, or if you have a polynomial that's just so large and so difficult to work with, and maybe when you plug it into your calculator you can't quite see it. And so this just sort of helps us narrow down out of all the numbers we could possibly pick out of, where do you start? Well, this is our starting point. So I'm going to start with that positive 1, and I'm going to try to use synthetic division to figure out if it is a factor. Because remember, if I use synthetic division, then it should have a remainder of 0 if it's a factor. That's what we did yesterday. So let's see if that's true with a positive 1. So I'm going to bring down that first number. 1 times 1 is 1. Add downwards to get negative 7. 1 times negative 7 is negative 7. Add downwards to get 4. 1 times 4 is 4, add downwards to get 24. So my remainder for this one was not 0. So this one doesn't work. Let's try the next one, negative 1. Carry all these over. There we go. Carry down that 1. 1 times negative 1 is negative 1. Add downwards to get negative 9. Negative 9 times negative 1 gives me positive 9, which I can add downwards to get 20. Negative 1 times 20 gives me negative 20, which cancels out to give me 0. So this negative 1 did work. So instead of, starting back at the beginning with a positive and then negative 20, what I'm going to do is actually use these numbers that I have here. Because remember, when you are factoring, or when you're using synthetic division, this piece we can bring down. This is a factor. It's x plus 1, right? Well, and then this piece up here originally started off as x to the 3rd, but after we divided it, it's going to become, okay, there we go. It's going to become x squared. And so I'm going to rewrite my trinomial as saying x squared minus 9x plus 20. And then I'm going to use just the x factor. So negative 9, positive 20, that's 1 and 20, 2 and 10, 4 and 5. And I can see pretty quickly I need 4 and 5, specifically negative 4 and negative 5, but 4 and 5. And now I have all of my factors, and I can find my solutions by setting them equal to 0. I can say, okay, x is going to be negative 1, x is going to be 4, and x is also going to be 5. And so this is the rational root theorem. For the standard class, it's the same idea, except all we're doing is we are just looking at our picture here, and we can see that we have an x-intercept at 1, 2, 3 locations. And this is all we care about. So yeah, it sort of hits up here and it sort of hits down here, but we don't care about that. We only care about this line, this x-axis right here. So when you see your function or your graph hit that line, that is what you care about. So we can actually see visually from a graphing calculator that we have our a solution here at negative 1, a solution here at 4, and a solution here at 5. So for most of you guys, I told you the general idea, the general steps of what you need to take to get the right answer for this. The first thing that you have to do if you are in honors is I need you guys to put all the possibilities here. So if we are doing example 2.1a, which is on the left-hand side over here, then we are going to focus on our constant 30 and just put our factors of 30. That's going to be positive and negative 1 and 30, positive and negative 2 and 15, positive and negative 3 and 10, and positive and negative 5 and 6. Okay, and remember this is our possible x values. Didn't mean to put 30 there. Okay, this is the step you have to take if you're in honors. But if you're in standard, you start at a different location. You actually start at step 2 for the honors class. So at this point, everybody should be on the same track. Everybody should be doing the same steps. And that is by going to the calculator and finding what is what does this look like? So let's put that in the calculator and see what it looks like. Okay, so here we are at this, the picture of this calculator. Let me back up a little bit. There we go. This is what it should look like. I put this in on Desmos, and we can see pretty clearly that we hit here, here, and here, and we can put those values. We can say this is -1, this is 5, and this is 6. So we know what our solutions are going to be. So let's go back and write that in. So our possibilities, or where the graph hit the x-axis, was at x equals -1, 5, and 6. And again, we're doing the same thing. Now everybody's doing the same thing. We can find the factors pretty easily, and then we have to do our synthetic division. So we're going to start with synthetic division and prove that these are in fact our solutions. So we're going to start with -1. I'm going to carry down my coefficients up here, and we're going to just do synthetic division and make sure that it works out. So I just sort of skipped ahead a little bit, since this should be pretty straightforward and really review for you guys. But we see that we have a remainder of 0, and so now I'm going to keep going from this point, not from the beginning. From this point, I'm going to continue with 5. So carry that down, get all this, and I see that I do in fact get a remainder of 0, so we have to do it one more time, but with the 6. That'll be, yep, it works out. So I have my factor of remainder, my remainder ends up being 0. And if I want to put the factors of this polynomial, all I have to do is set each one of these equal to x and make it equal 0, because that's how I got my solutions in the first place. So if it works one way, it's got to work the other. So we can say that this is going to be x plus 1, x minus 5, x minus 6, and those are our factors. All right, same thing with example 2.2. We're going to, for honors only, we're going to write the possibilities. Oh, hold on, there we go. We are going to write the possibilities of 24. That's going to be positive and negative 24, positive and negative 2 and 12, positive and negative 3 and 8, positive and negative 6 and 4. I made a typo. 1 second. So we're going to erase that. I'm going to make it a different color because I accidentally had a typo. I still made a typo. It's 6, guys. I do know multiplication. I just struggle sometimes. Okay, so we are going to now look at our picture. Let's go to our graph and see what it looks like. Okay, so this is what the graph looks like. We see that it hits here, here, and here, and those numbers are going to be -2, 1, 2, 3, and 4. So we know we have a solution at these 3 spots, so let's go back and write that down. So x is going to equal -2, 3, and 4, and now I have to prove it. So I'm going to start with my synthetic division. My leading coefficient is 1, followed by a -5, -2, and 24. Carry that 1 down, do the synthetic division, and we should end up with a 0, and we do. Again, we are not going to start back at the beginning here with this line. We're going to use the 3 and move it to this line and use synthetic division there. So that should, again, give us, to be a negative right here. My bad, a -12 right here. 12 minus 12 gives me 0, so that works out as well. Then we move on to the 4. Okay, again, we're starting with where we left off, and we do end up with 0. So I can say that these solutions are in fact true, and I can also put the factors. Again, I'm just showing you, as we are dividing, it starts off as x cubed from here, and as we divide each time, they reduce by 1 of the exponent. So it was 3, now it's 2, now it's 1, and then it's 0, and it goes away, so it becomes a constant. So again, this is going to be x plus 2, x minus 3, x minus 4. That is our answer. And then again, our solutions that we found earlier are x equals -2, 3, and 4. So that is this section. Hope it helps you. Good luck on the homework. Again, please text me on Remind if you have any questions.